Hey, how you doing? Sean Tech here. Hey, so I wanted to kind of do something a little bit like kind of a combination of hey, let's look at this before. Like we've talked about soldering a couple of times, and I wanted to show what soldering is basically for a through hole, what we call a through hole component. Hmm. Now, excuse me, I'm incredibly thirsty for a cup of coffee right now. Some of you who have taken an electronics class may have at some point seen something which looks like this. This right here is what we would call a resistor. It's like the world's most basic electronic component device that essentially the right way to phrase this, it blocks electricity. It doesn't block it. It resists it, is what it does. It opposes it, depending on what the material is on the inside of this it's made of. Usually, most like general starter electronic classes or starter kits come with these sorts of things, and they get plugged into something that's called a breadboard. Now, what a breadboard is, gosh, I'm looking to see if I have one handy by me. And I don't see one. Oh, wait a minute. Wait, I might actually have. Oh my God, I'm breaking the camera. Look at over there. That one over there. That one. No, that's not one. That one. Ah, that's one. Yeah. Okay. Yeah. I got one. Sorry about that. I got stuff. There's stuff all over the floor. Yeah, I don't think you ever want to see the floor in terms of what this place actually kind of looks like with that. Breadboard looks something kind of like this. All right. Although mine's got a whole bunch of stuff on it from a previous project, and/or me storing things on there. Look at that Radio Shack. Not around anymore, unfortunately. But anyway, what you normally do with like electronic component like this is you take it and you plug it into the breadboard, kind of like this, and it eventually becomes connected up to form your simple hobbyist circuit. Now, most circuits don't look like this. Is just like your hey, I gotta plug things in, try things out, blah blah blah, real quick stuff, that kind of thing. You know what I mean, right there. So, the this normally, if we want to connect two of these together, for instance, I've got two of them in my hands here. If we want to connect two of these things together, the only way to actually really do this is to use a kind of a soldering tip in order to do this if we don't have a breadboard. Now, underneath the microscope, here we go. We'll put the resistors underneath the microscope right there. That is a terrible picture. Look at that. Holy cow. Let's do a little bit of some white. And that, I feel like, is even worse. That's where it is. I'm trying to do a white balance so that you can all see kind of what this is here. Well, let's try going over to the exposure. Let's try to kick that up a little bit here. Is that happening? Can I do a manual white balance? Is this a thing? I don't need to necessarily have that much in the reds. That's actually just about right there. That's about their natural color in terms of what this looks like here. There about. I'm gonna try to kick up the gain just a little bit. So what you'll notice on here is that each one of these little resistors that are on here, they have little stripes on them. If you can see that, and the stripes actually are a color code that indicate the quantity of electronic resistance value to it, which we can talk about later. It's called the RMA color code, and each one of the bands means a different number. But we can actually talk about that a little bit later when I hadn't intended originally to do anything like that. What I wanted to show you is that like right now these two guys are entirely disconnected. And it's possible to connect these two guys up by kind of coming in and do a little twist, doing the old twist tie, so now they're all twisted up right there in what they look like now that we've got them all twisted up, connected together. Now if I really wanted to, though, I could kind of pull those guys apart at this point. Well, I mean, like here I can see. I'm gonna see these two guys here. I'm gonna pull them apart just like that, and they come apart. That was kind of weak. Here, let me try that again. All right, so I'm gonna twist it up a couple of times, right? So now they're pretty well twisted up, and then and a small amount of force. I'm not that strong, so a small amount of force essentially pulls them apart. But what I'm gonna do with these guys is I'm going to kind of twist them up together here. like this, right? So they're twisted up right there at that point, and I'm going to lock them into place using something that's called a helping hand. It's essentially a stand with a couple of alligator clips onto it right there. This is actually the original one that I used to use back in the early days of college, me. And so now we'll go down over to here. Let me kind of move this over so that we're a little bit show a little bit of what the microphone is there. And now I've got them focus up to it on there. I've got the resistors connected with this alligator clip. One of the things that we can do is we can solder these two electronic components kind of together. We do that as such. First thing we do is we turn on our soldering iron. The Hako station that I'm using right now actually heats up pretty darn quick. I'm going to be using my bent tip Hako iron. This one's a little bit larger in terms of install size. Some of you may have even seen this before if you are watching from other areas there. So now I've got this soldering iron. Then let me kind of move this a little bit more to where this into place. I've got this soldering iron. Notice that the tip of the soldering iron is a shiny tip. Can you all see that? The rest of the soldering iron doesn't quite look. It looks a lot less dull from the imaging. That's not entirely too dull in terms of what that is. But the general rule of thumb is when soldering, always use a shiny tip. The reason being is that there's this thing out there called conduction, and conduction essentially means that there is some sort of an easy pathway for something to travel through. Like electrical conduction means that electricity flows through it. In the case of this, we're talking about heat conduction. We want heat to actually go from one spot of the wires over to another. Because what I'm going to do is I'm going to take some solder wire off of my spool here, and if I just touch the solder wire down to the tips of my electronic resistors, you notice that it's not really doing anything right now. If I touch it to my soldering iron itself, it actually gets quite hot when I tin the tip of my soldering iron. So what I'm going to do next here is with a nice tin tip, which is what I have right now, I'm actually going to just touch. I'm just touching kind of the edge of these resistors. See that? I'm really just touching just the very edge. Now watch what happens if I leave that sit. The heat is conducting from the soldering iron into the actual metal parts. And what that does is that means that the other metal parts, metal is a pretty good conductor of heat, is what it is. And if I touch the wire now with the little parts of the wire here with the solder, see what's happening to it? See what's happening to the solder? It's beginning to melt on the actual resistor tips themselves, and that's because heat is actually going all the way down and through the pieces of metal. It's conducting. It's traveling its way down and through. I'm gonna put a whole bunch of it on here, so I'm gonna just kind of coat this thing over. See how it flows all the way down like that? So heat is actually going all the way through. Now I've taken the heat away at this point, and now what I am left with, if I zoom in a little bit better than that, I am left with a solder joint at this point, which if I were to touch this right now with my tweezers, the solder joint does not. Let me try and increase because I've zoomed in a little bit. I'm gonna increase the gain up here. I'm gonna switch to my right hand here and move the gain up a little bit here just so we can see this a little bit better. All right, so at this point now, my solder is solid right now. The solder itself is in its solid form, but as soon as I touch just the tip of this to it here, you'll notice that what will happen is if I let it sit there for just a little bit, see that it started to melt. At this point right now, with the heat applied, this is actually entirely liquid at this point. And if I take this away, it will re-solidify upon getting back to room temperature again, and it is now back to a solid. This is kind of a cool thing to be able to do something like this here. The solder that is on here can go very quickly back and forth between room temperature and high temperature based on the amount of heat that's actually conducting through it. And so the resistors at this point, they're cool enough to the touch. I could have probably touched that about 5 seconds after I had removed that. Don't try that at home necessarily. You might solder is hot. Don't burn yourself. Don't be a dummy if you are like me and you grab this and it's too hot and you might get an ow at that point. So, but at this point, what's kind of neat about this is that now, if you look carefully at that, those are connected together, both electrically and mechanically. In fact, if I'm trying really, really hard to break this apart, and that's not breaking apart very easily right now. In fact, if we were to look at this, this is actually still pretty well connected up together. Only a small portion of it broke right there, nearing the largest amount of force that I'm applying down to the leads. But that's kind of cool. It connects itself together. This is one of those things that jewelers love to use for what they do, because it forms such a nice connection if it's done correctly. There are ways to do soldering which is done incorrectly, which we hope to kind of demonstrate in a couple of videos. The main thing you don't want to do, don't blow on it to cool it down quickly. You cool it down too quickly, you will create a cold solder joint, and cold solder joints are doomed to failure. They are doomed to fail at some point along the way. But anyway, a little demonstration of how solder flows down through the wires, and you can heat it up and cool it down very quickly with a tool like a soldering iron that we're using here. So thanks very much. Hey, let me know in the comments if you're interested in checking out anything else. I'm open to a lot of stuff with it. Let me know if you think they're cool, they're not cool. Let me know what you need, and we'll see you on the next one. All right. Hey, see you around, folks.